Welcome, everybody. I'll start off as usual with a little bit of recap of last time. I always worry that I'm in the situation that Wilfred was in, that was characterized, Sellers, that was epitomized in the entry under his name in the Philosopher's Lexicon that Dan Dennett created, using philosophers' names as ordinary words. And the little vignette for Sellers was, I'm sorry, Your Holiness, whenever you explain the Trinity to me, I understand it, but when I go away and think about it on my own, it goes all Wilfred in my mind. And so I worry that things may go a little Wilfred after we leave here. Last time, my main theme was raising sortal consciousness. That is just becoming more aware of the crucial role that sortal kind concepts play if we're using singular terms. It's crucial for counting. You can't count things, units, entities, objects, particulars. Those are all stand-in terms, placeholders for genuine sortals like tiger and number and photon. And I talked last time about this relation between sortals, singular terms, and identity claims. So it's one thing to see properly, as for instance Leibniz already did, that to use a singular term, an expression that in Quine's phrase purports to pick out one and only one object, there has to be, to use that, the crucial use of it is in identity claims. Frege understands better than most, but it's still a Leibnizian idea that, as he puts it, in intersubstitution, all the laws of identity are contained. But it's another thing to see that that constellation, singular terms and identities, depends on sortal concepts, sortal kind concepts being in play. And the sortal kind concepts contrast within the category of kind concepts with mass kind concepts like water and gold, and all those kind concepts which, in order to get countables, need some kind of classifier like chunk of or cup of, something like that. Then you get sortal kind concepts from them. And both those classes of kind concepts contrast with merely attributive predicates like red or large that characterize but aren't sufficient to individuate by themselves. So I wanted to talk about a couple of consequences of this. I mentioned the tradition, starting with Geach, that concludes that identity must be sortally relativized from the fact that singular terms need to be governed in their use, paradigmatically their use in identities, by sortals which supply the criteria of identity and individuation that identities depend on. I mentioned Geach's conclusion that identity itself has to be sortally relativized, and claimed, though we can't go very far down this road, that you don't have to draw that conclusion. That's one way to go, but you can still treat identity as absolute as long as you treat the singular terms that flank the identity as suitably sortalized, suitably governed by sortals. Now, here's a consequence that I didn't mention last time, and that is there's a big difference that becomes visible here between a possible worlds framework on the one hand and a Tarskian model theoretic framework on the other hand. And it comes into view when you think about the sortals involved. Models come with a domain, a set of, as they say, objects, which have to have been identified and individuated somehow already in the semantic metavocabulary you use to specify the domain. But having done that, it makes perfect sense to talk about the cardinality of the domain. How many things are in the domain? Now the domain might have 12 tigers and 2 photons, some numbers in it, and those are all going to be individuated by sortals that are outside the model, but it still makes perfect sense to ask, what's the cardinality of the domain? How many things are in the domain? Possible worlds don't come with domains. If you want to count things in your possible world, that's relative to the specification you give of the possible world. You need to specify, when you're saying what possible world you're talking about, what's in it. But you need not say, for most uses of possible worlds, and for the ones where this is not true, you should be suspicious. For most uses, you don't need to say what all the things in the world are. You're comparing one possible world with another, and there's some features of difference between them, and those are the ones you specify. You don't have to talk about everything that's in the world. And that's a good thing, because the sort of criticisms that Geach is making of sortly unrelativized, wide-open quantifiers of the sort Frege uses in Grundgesetze, the sort that's used in Principia Mathematica style first-order logics, there isn't any analog of that in possible worlds. And this makes a difference when people are inclined to use model theoretic arguments to draw conclusions about possible worlds. A good place to start for a critique of that sort of move is John Etchemendy's fine book, The Concept of Logical Consequence. But the issue looms large if you look at arguments that Stolnecker or Jaegwon Kim make about supervenience of one vocabulary on another. And they want to think about that in terms of every possible world in which the facts specifiable in one vocabulary make this true, they make these other facts specified in another vocabulary true, that sort of supervenience claim. And that's fine, but using model theoretic arguments to draw conclusions about supervenience understood in terms of possible worlds is a very delicate matter. You've got to be very careful about the sortals that are involved. One consequence of possible worlds not coming with domains is that the sort of claim that I was rehearsing and sort of snarky about last time, Pavel Tiki saying, look, I only understand possible worlds with a finite number of things in them. And furthermore, one other claim, and it's got to be the same number. But you can count, you can give a cardinality for a domain, but not for a possible world. Another point that I gestured in the direction of, but I'm minded to make a little bit more of this time, the notion of everything involves a quantification, in effect, over all possible sortals. I mean, you could restrict it to the sortals that are in our language, but that's seldom what you mean when you say everything, even things that fall under sortals that we don't happen to have now. Typically, we want to talk about those things as well when we say everything. When Frege says that concepts have to have sharp boundaries, it must be determined for every object whether that concept applies to it or doesn't. We want to know where the sortals come from. But the notion of all possible sortals is particularly fraught in the context of techniques for generating new sortals from old ones. Any set of sortals that we have mechanisms for introducing new ones to them. Now, I mean, mathematically, that doesn't mean you can't assign numbers to them if you can make sense of a notion of sort of the limit ordinal of those and so on, but nobody actually worries about that in making these sorts of claims. And the point I wanted to make now is that notion of everything is mirrored pretty exactly in the notion of nothing. In particular, if you think about the notion of the empty set, that's a set with no elements. So I say, well, so you mean the empty set has no tigers in it? They say, yeah, that's right, there's no tigers. And no photons, right? It doesn't have any numbers in it, right? It doesn't have anything in it. For any kind of thing, the number of things of that kind that are in the empty set is 0. Now, as Frege says, when you ask a how many question, one of the answers that you better be prepared for is 0. That's how many tigers are in the room with us right now. That's a perfectly good notion. That's a set whose number is 0. There are no tigers in the room with us. And a set that has no photons in it. That's a perfectly good set. Its number is 0. I mean, I need to give some specification of it. And maybe inside the black hole there are no photons. That's okay. But the empty set, the is marking a definite description. The specification of an item falling under the kind set, sets defined by their elements, and that means the set that has 0 tigers in it is identified as the same set that has the divisors of 17 other than 1 in itself in it. And the question is how you're going to justify or even understand what you're saying when you say, no, I want the set which corresponds to all sortal kinds that have number 0 associated with all the sortal concepts with number 0. Those are all the same set. Now, there's an axiom in Zermelo-Fraenkel set theory that says there is a set with no elements, and the axiom of extensionality in the logic we're using to reason with that, from that it follows that there's just one set that has no elements. But the question is, what does that mean? What justifies that definite description? It requires a quantification over some set of sortals that you use to individuate the things such that everything of those kinds is not in the set we're talking about. I mention this because one of the crucial differences between applied set theory and pure set theory is that you elaborate pure set theory starting with the empty set and its unit set, and you go on from there. And I'm suggesting there's a sortal fishiness about the notion of the empty set, just as there is about the set of everything. I mean, this comes out in set theory, and you better not be talking about a set of everything that includes every set. We know that problems come up with that, but I think that's more generally appreciated than that essentially the same considerations apply to the empty set. It's perhaps worth noticing that a corresponding point applies to mereology. I think I've mentioned the null element in mereology that sort of completes the lattice by giving it a bottom that's considered a part of every whole. In mereology, of wholes and their parts instead of sets and their elements. That isn't really where the problem is. The null part doesn't raise any problems that atomic parts don't raise. Atomic parts are wholes that don't have any parts other than themselves. They have no parts. Well, you're quantifying over all the parts, all the wholes, and saying, well, none of those are parts of these atomic wholes. Frege, having made so much of this point, articulated it so well in the Grundlagen, we could be disappointed to see that after 1884, he never talks about them again, never specifies the sortals that he's working with, and that comes around and bites him. Axiom 5, the notorious Axiom 5 of Grundgesetze, that defines courses of values that get introduced in the essay we're talking about today. It desperately needs some attention, some acknowledgement of sortal concepts in it. It's the first place where the wide open quantifiers show how dangerous they are. The response to it, the first successful one being in Principia Mathematica, precisely introduces types and says you have to think about the kinds of things that you're introducing and distinguish those explicitly, the ramified type theory of Russell and Whitehead. But most logics that we teach in philosophy departments don't involve explicit representation of the sortals that are used to individuate the items that the individual constants and the items that the individual variables range over the domains. We just don't talk about it. And that's true in classical first order quantification theory with identity. But it's not as though that notion has just been lost. As I mentioned, sortal concepts come in to solve a problem in Principia Mathematica. Alonzo Church, in his typed lambda calculus, which is the most sophisticated representation of functions in exactly Frege's sense, introduced a systematic way of thinking about types. And modern type theory, post-Church type theory, I identify it most with the work of Per Martin Löf, a Swedish logician. His intentional intuitionistic type theory is a theory of sortals, of kinds. Type theory, as we've come to understand it downstream from Martin Löf, it starts with some primitive kinds, primitive types, and studies the constructors that you can use to produce new kinds from old kinds, new types from old types. So, for instance, a particular constructor will take any object of type A and any object of type B and produce an object of type A cross B that is something like the ordered pair of an A and a B. Type theory, in that sense, is absolutely foundational for contemporary computer science. I complain that philosophers don't typically learn type theory, but every computer scientist learns it in their 101 course. That's the theory of the kinds of data structures and the different functions apply to different kinds of things. So you've got to keep track of those. And again, if you think about record structures, data structures, you start off with some types of things, dates, strings, integers, floating point, and you can build data structures that specify what kind of thing goes in what place, build that to the sky, and then your procedures operate on those things. So you've got to worry about the type theory. So there is a good, indeed, a whole field of formal studies of sortals. It's just philosophers typically don't learn about them. We should. At the high end, sort of downstream from Martin-Luff, is the HOTT, homotopy type theory, that I mentioned last time, in no small part a product from across the ravine. The group around Steve Audi are principal in talking about that. Okay, all of those are just a few more consequences, things to think about, things to be wary of if you have raised your sortal consciousness in the way that the Grundlagen ought to have done, because these issues come up sort of across philosophical discussions, particularly metaphysical ones. Okay. From a bookkeeping point of view, let me say this session displays the first slippage in the syllabus for the course. I'm only going to talk about the function and concept essay this time. It turns out I'd sort of forgotten just how many moves get made in this essay, and we can't talk about the concept and object essay. We're just today. I mean, we will next time, which let me remind you is 2 weeks from now, and I hope to do on sense and reference. Then we certainly will talk about it. We'll see how much that slides. But anyway, for today, it's just this one essay. And it is remarkable. The Grundlagen comes out in 1884. This essay is from 1891. So it's 7 years during which he publishes nothing. And in fact, we don't have notes or anything. His papers were by and large destroyed in the Second World War. All we know about what he was doing during this time in a scholarly way is he started off with a Grundlagen and he got to here. And that's really enough. I mean, I'd be interested in sort of the order in which he had these various ideas, but what he does is to take those topics, in particular the notion of a singular term and the notion of singular terms as having their conceptual content settled by the intersubstitution licenses that they constitute. So that to say A is identical to B is to say that for any property predicate, for any function f of A, if f of A, then f of B, and if f of B, then f of A. He's going to take just that idea and the notion of function that was already in play and build an entire metaphysics out of it. And it's an intricate and fascinating metaphysics that in many ways I don't think has been fully explored. It's as rich and deserves comparison with the ontology of the Tractatus, which has been intensively studied. Not to say that we see our way to the bottom of it, but in particular, the metaphysics, the ontology that he puts in place in this essay has not had that same sort of attention to it, working out the consequences of it, what are the problems with it, and so on. I should just mention, when I say we don't know what Frege was doing during these 7 years, as far as his academic life is concerned, we have all the records from the math department of his time. We know that although the Grundlagen fell stillborn from the press, to use Hume's phrase, it was not reviewed. There's no references to it in the years after it was published by anybody else. They did grudgingly promote Frege, gave him a permanent salaried position, so he wasn't a Privatdozent who had to be paid directly by his students anymore. But it was an irregular professorship, and even that, it was an irregular professorship which statutorily gets exactly half the salary of an ordinary regular professor. And Jena, during these years, was ranked 20th out of the 21 German universities in terms of its sort of academic quality. And the math department in particular was considered so bad that they couldn't get Privatdozenten anymore. Nobody would come to try and teach their math students. And so they had Frege doing exactly the same courses that he was doing as a Privatdozent. And when a regular professorship finally came up in 1896, they didn't give it to Frege. They made him an honorary ordinary professor, which had the honor, but it had the same salary, half the salary of a regular professor, and that's what he became emeritus from. So they had him teaching the very most elementary stuff, and hired somebody who did number theory and higher analysis, because that was real math, as opposed to whatever it was Professor Frege was doing. So he was really treated incredibly shabbily by his department, particularly during these years, and had no one to talk to, but he was thinking. In this regard, you can think about Kant, who had no philosophical conversation partners. Okay, so Frege sets himself the task of seeing how much juice he can squeeze out of the idea of objects, functions, and identity, with the idea that the inferential role of at least one kind of sentence he completely can specify. Identity sentences, ones that express the identity of, ones that have singular terms flanking the identity sign and express the recognition of an object as the same again. Those are intersubstitution licenses for any functions that you apply to those things. You're licensing the inference from the one to the other. All the laws of identity are contained in intersubstitution. Now here, though Frege doesn't make this division, this principle that he's understanding in substitutional terms. A few times from now, we'll look at Bolzano, who's doing the same thing. Leibniz's law about identity and indiscernibility, that identical things have all the same properties. We can actually divide it into two parts: the indiscernibility of identicals and the identity of indiscernibles. So the indiscernibility of identicals says if A is identical to B, then there's no property that A has that B doesn't, and vice versa. This is the principle that we used to distinguish Goliath the statue from Lumpel, the lump of clay, because if you think about subjunctive properties, what would be true of it if the shape were radically changed, we see, well, there's a difference. That would destroy Goliath, it would not destroy Lumpel. It's hard to call what you have identity if you don't have indiscernibility as a consequence of it. At least some range of indiscernibility. That's the indiscernibility of identicals. The other half, the identity of indiscernibles, says if A and B have all the same properties, then they're identical. That's been traditionally a more controversial claim. It sort of depends. Are there maybe properties that you're not quantifying over, that you can't express in the language you've got, that do distinguish them? Maybe they're just indistinguishable by the expressive resources that you have to bear, or the vocabulary that you're using to try to distinguish them, but some richer, expressively more powerful vocabulary would have the expressive resources to distinguish them, to characterize, to specify a property and or a relation they stand in that one does and the other one doesn't. So this is distinguishing the if from the only if part of the identical if and only if indiscernible. And making that distinction, I have to mention the analytic Marxist Jerry Cohen, who pointed out how difficult it is in ordinary philosophical English to distinguish these. So somebody says, well, I mean, they're identical, they're indiscernible if and only if they're identical. And he says, no, I don't believe that. I mean if and only if. That is, how would you specify that you only meant the one direction? I mean if, and I mean only if. I don't know, that's supposed to be a joke. But dividing up Leibniz's law is one of the cases where you might find yourself trying to perform the Cohen Speech Act. Okay, so the essence of the new ontology, the new meta-conceptual framework that Frege is putting in place, is what I think of as Frege's mastered formula. A equals B, if and only if, and now we've got a schematic function here. For any function, f of A is identical to f of B. And, well, we've got these identities on both sides, but we know how to understand them. For these to be identical means that for any G, the result of applying it to f of A and f of B has got to be the same. Those schematic f's are function expressions. I say this is the master principle of his metaphysics. He makes a couple of surprising, I think, bold moves at this point. One of them I mentioned in our very first session, and Frege uses this move to organize the narrative of the essay function and concept, and that's this radical generalization of the mathematical notion of a function. As he's telling the story, you start off where the arguments and values of functions are always numbers. That was the origin of the concept of function, and the notion of function got broader as the kinds of numbers were expanded. And these were two sides of one coin. expanding from counting numbers to the integers by including the negative numbers, including rational numbers as arguments and values of functions, and what had most recently been well figured out in the first half of the 19th century, extending to complex numbers, doing analysis functions of a complex variable. That's typically the first year course in a math major that breaks people's spirits. And that stuff was mostly figured out already by Frege's time. He says, I'm going to extend the notion of function in a way that goes beyond what the mathematicians ever conceived. I'm going to cut it completely free from the notion of numbers. I'm going to have a notion of function that allows as arguments and values objects of any kinds. So a perfectly good function for him is capital of. When you apply that to Sweden as an argument, you get Stockholm as the value. I think it's hard for us to realize how radical a step this was. Any of his mathematician colleagues would have thought that was merely a metaphor. You say, it's as though there were a function here, but they would have insisted there was no way to think precisely about functions in that sense, to be clear about them in the way in which they had become clear about, for instance, functions of complex variables, functions with complex numbers as arguments and values. Now, if we look at the formula I called Frege's master formula up there, there's the identity claim, which gives us a kind of sentence, a kind of conceptual content, propositional content, we could say, that we understand the inferential role of. We know what follows from one of your premises being A is identical to B, A equals B. It's substitutional. But in order to make that clear, we need to have another kind of symbol there. And that's the function symbol, a function that applies to an argument and gives you a value. That is not a singular term. It's not an expression that can stand by itself, flanking the identity sign. It can only do so if you give it an argument. So there's a crucial systematic difference, structural difference, in the inferential role that's played by singular terms and function expressions. Frege starts off, you sort of look at the passages I excerpted in the handout, saying the functions are incomplete. They don't designate anything yet, not any object. They're not singular terms. They can produce singular term expressions if you give them an argument. And then they're singular term expressions that pick out the value. Well, I said his first move was to generalize the notion of function to apply to objects. The second move, and this is the essence of the metaphysics, is to say, and that's what there is. What there is can be divided exclusively and exhaustively into objects and functions, into what you can pick out with a singular term and to what you can designate with a function expression. the difference between those two kinds of things we're going to have to understand in terms of the difference in those expressions by thinking of an expression like f of a as having the replaceable part, the singular term, where you can substitute b and c and so on for it. By thinking of the function expression like that, we grasp the function that it expresses. The function, like the object that A refers to, that's something in the world, not in the language. We only grasp objects in virtue of using singular terms that pick them out. We need sortals to do that, but they're off stage at this point. We can only pick out, semantically come in contact with functions by regarding an expression in a certain way, regarding the expression f of a as having a fixed part, standing for the function, and a variable part, standing for the argument, and thinking of the whole thing as standing then for the value, which is an object. So we can understand functions in terms of objects, but really we can, objects as what can flank an identity sign. The singular terms, picking out objects as what can flank an identity sign. But our grasp of what the identity claim says is in terms of an intersubstitution license, and that requires us to think about the other sentences, sentences like f of a equals f of b. It requires us to think about them as having not just the singular term parts, the parts that can themselves flank the identity sign, but also function expressions. And just as using singular terms that have been properly introduced and so on is the way we talk and think about objects, the way they become semantically accessible to us, which is upstream of epistemological knowledge about them. You have to be able to think about them in order to know anything about them already. And to think about an object is to use a singular term that refers to it. To think about a function is to use a function expression, that is to use an expression that is incomplete by itself, but designates an object when it's completed by an argument. So function, argument, value. Once you've generalized the notion of function, so argument and value can be any singular terms, and we're going to form function expressions from them, then Frege can formulate the view that what there is, I'm using that expression from Quine's famous essay on what there is, rather than everything, because, as we'll see, functions aren't things. Things are picked out by singular terms, identified and individuated according to their governing sortal. Functions are a different sort of thing. Now, we can't say that. Among what there is, one finds functions as well. Now, the essay we'll begin to talk about next week, well, 2 weeks from now, next session, concept and object. Once he's gotten to identify concepts as a kind of function, is an exploration of the paradoxical claim that the concept horse is not a concept. Because the concept horse is a definite description, It picks out an object, and concepts are functions, not objects. But how can that be? Anyway, we'll look into the tangles that he gets into on that subject next time. But here's a metaphysical vision. What there is consists of items of two very different meta kinds, objects and functions. Now, functions are every bit as much a part of the furniture of the world as objects are for him. He's a functional realist, which, given that he's going to understand concepts as a kind of function, means he's a conceptual realist. He thinks there's concepts out there for us to think about and think with. And the way we do that is by reasoning with expressions that have singular terms and function expressions in them. So he's very clear that our only grip on these two large categories is from the use in assertion and inference of claims in which these two kinds of expressions occur. Now, it's a related source of paradox, something I'll only come to at the end of today, that function expressions are not parts of sentences in the sense in which singular terms are. They're more like patterns that sentences can exhibit. This, just to have a label so I can bring this back, we have to distinguish predicates in the sense of Demetian simple predicates, which really are part of the sentence, and complex predicates, which are patterns in them rather than parts of them. But I got to get a lot of other stuff on the table before I can explain what that means. I say these are supposed to be exclusive categories. Nothing can be both a singular term and a function expression, and that's marking that if something is an object, it's not a function. If something is a function, it's not an object. But they're also, this division is exhaustive. As he says in the passage from page 32, that's one of the passages from that page that's on the handout, an object is anything that's not a function. And vice versa, but you've got to be working in this framework for that to make sense. Now he proposes to do and say everything using this meta vocabulary of objects, functions, and identity, where the only kind of sentence that we start off understanding is identities. And we're going to understand other sentences on the model we use to understand identity sentences. That is, entirely in terms of the objects that are picked out by the terms flanking the identity sign. This is where the name bearer model as a semantic model comes to the fore. And I think it's not too strong to say. That where the order of semantic explanation that we saw in the grip shrift goes from implications it's not supposed to be legible, you just have to remember what I say it means when I write it down. It goes from implications to sentences to singular terms. We start off with a division of the implications, thought of as a set of premises and a conclusion, into the good ones and the bad ones. Not the logically good and logically bad ones, just the good and bad ones, as we can see, because he says I could start with the implications of rational mechanics, let's say, and then we use the method of observing invariances under substitution to group the sentences together in ones that have the same conceptual content, Inhalt, where we understand that in terms of their having the same conceptual content, just in case substituting one for the other never turns a good implication into a bad one. That is, they're intersubstitutable salva consequentiae. And then we understand singular terms. That's, as a premise, the same things follow from it, he says. He takes that to entail that they will have the same role as a conclusion. I mentioned you can relax that requirement. But then we sort singular terms according to their conceptual content, sharing a conceptual content, even though they can't play the role of premises or conclusions in inference, but we can still look at an implication and say, if in that implication we substitute B for A everywhere, does that ever turn a good implication into a bad one? If not, they have the same conceptual content. But this is a top-down order of explanation. We're starting with the big thing, the implications that consist of pairs of sets of sentences or something like that. And then we understand the role of sentences in terms of the role they play in the implications, using the substitutional scalpel to assimilate them. They have the same conceptual content. Think of the lines have the same direction in case the lines stand in this equivalence relation of parallelism. The sentences have the same conceptual content in case they stand in the equivalence relation of being intersubstitutable, saving the goodness of implications. So we introduce it by abstraction, and we get the equivalence relation we need for abstraction by substitution. Intersubstitution, or you don't get an equivalence class, but that's what's licensed by an identity. So we have this order of explanation. Frege is going to lay alongside that something that has sort of been in play all along. So notice that I could say all of this without using the word true or truth. It just isn't necessary in mentioning this. Some of the sentences are true, some of them are false, that's fine, but we don't have to care about that in order to do the top-down order of explanation. But he's introducing a bottom-up order of explanation that starts with the singular terms referring to objects and goes to sentences thought of as the application of a function to an object. And then we're going to understand implications. Well, what is it in the world that goes with those? Well, it's relations among functions and objects, ultimately relations among objects that we get. But the point is there's this other order of explanation where we're going to look at the reference, the Bedeutung is his term, the reference of the singular terms, what object is picked out, and we're going to go to the truth values of sentences, and then to the goodness of implications. So what I want to explore now is this bottom-up order of explanation that goes with his new way of thinking about things. Now, Michael Dummett, who ushered in the modern golden age in Frege studies, says of this move that Frege's shift from thinking about logic and semantics as being about consequence, as he does in the Begriffsschrift, to thinking of it as being about truth and reference, as he does here, was a giant backward step. He said logic had always been traditionally about consequence, a relation among sentences, and thinking about it in terms of a property of sentences, truth and logical truth. He says that just tangled us up philosophically in thinking, in trying to think clearly about logic and formal languages. I think he's mischaracterizing what happens in Frege. I think both these orders of explanation are still in play, and that when what happens, I'm issuing a promissory note here as we look at on sense of reference and then the Grundgesetze, I think what happens is Frege splits up his notion of conceptual content into one that's top down and one that's bottom up, and he calls the first one sense and the second one reference. So he says now to think about the semantic content of an expression, you have to think both about its Sinn and about its Bedeutung. And that division of the notion of content into two parts, I think lines up with these two orders of explanation. And I don't think the Begriffsschrift order ever goes away, even though expositorily, from here on out, he's going to favor telling the story that turns out to be he tells the story from the reference side to the sense side, rather than in his expository strategy treating them as two sides of one coin, which is what I want to claim his better wisdom is anyway, and in fact his view. So one of the things we want to keep our eyes on is how this bottom-up order of explanation works. So here he makes a move that, although it's the basis for modern quantificational logic and identity for our logistical languages, has been thought to be suspect sort of right from the beginning of people thinking about it, which was in his case not immediately, but soon. And that's to assimilate sentences to singular terms. He's still going to distinguish them, those are different categories, but semantically he's going to think about both of them using the name-bearer model. What Sellers called the Fido model. Fido is the name of the dog, and Fido is the dog. That model of semantics, do I know what you're talking about with when you use Fido? Well, if I can point to the dog, then I do. I know who Fido is as well as what the word is. I mentioned that Frege was vastly extending the mathematical concept of function that he inherited. You can say parenthetically, his Habilitationsschrift was on the concept of general magnitudes, that is, a generalization of number. And he wrote there very early on about, well, what is the concept of a magnitude? It's something you can compute with. You can apply various functions to, paradigmatically, an addition-like operation, a multiplication-like operation, and so on. He was already thinking about this, well before Begriffsschrift. But now, thinking semantically about sentences, at least to begin with, as singular terms, the crucial thing, he says, is to think about identities of a sort that no mathematician would purport to understand. An identity that has sentences on both sides. What do you mean those are identical? Well, they've got to be intersubstitutable as arguments of functions, saving the value. That is, applying a function to this to get a value has to always give you the same value that applying that function to this does. That's what that would mean. That's what identities mean. Well, what are the objects here? And he says, well, if these things are intersubstitutable, then I'm going to say they have the same truth value. If this one is true, that one is true. If this one is true, that one is true. That's the equivalence relation that I'm going to use. And just as we introduced conceptual contents of sentences by abstraction and substitution, we say if the sentences are intersubstitutable as premises of implications, salva consequentiae, saving the goodness of the implications, then they have the same conceptual content. Well, if these two are either both true or both false, then we're going to say they have the same truth value. And he introduces these objects. Among the objects in what there is are truth values. He's not eliminating or eliding the distinction between singular terms and sentences. We can still tell the sentences apart. They're the ones that pick out a very special kind of object, truth values. Here, let's look at yeah, this is the bottom of page 1, going over to 2 from 29. So he says we've moved on from thinking of the arguments and values as being numbers to allowing objects. But now I want to think about this function x squared equals 1, and let's apply it to different arguments. It gives us a list. Of these equations, the first and third are true, the others false. I now say the value of our function, the equation thought of as a function, we're taking some bits of it as replaceable, is a truth value, and distinguish between the truth values of what's true and what's false. I call the first for short the true, and the second the false. Consequently, the sentence 2 squared equals 4 stands for the true, in the same sense as, say, he says, 2 squared stands for 4. I think about the conceptual move that he's making here. 2 squared stands for 4, and in the same sense, the very same sense, the sentence 2 squared equals 4 stands for the true. This is just an astonishing leap of metaphysical and semantic imagination. And you might say, yeah, and can that really be a good idea? I mean, this is really what Dummett was objecting to. Accordingly, the expressions 2 squared equals 4, 2 is greater than 1, 2 to the 4th equals 4 to the 2 stand for the same thing, viz. The true, so that in 2 equals 4 equals 2 is greater than 1, we have a correct equation. I don't know, any thoughts or comments about this move? Yeah, Nikki.
I find it puzzling that it's couched in precisely these terms, standing for, because if we take Fregean reference, what he calls Bedeutung, if we tune into the metaphor there, Bedeutung, deuten, pointing at, right? It's at once interpreting and pointing at. I get that metaphor. I guess I get why a singular term in its Bedeutung would point to an object in the same way. It's the same gesture towards an object as to the true. But I don't get why it's the same sense of standing for, because I can totally see the for in the two in the
singular term.
In the singular term.
You're happy to say.
I don't know what it is to stand in for the true. Certainly not in any useful way.
So you're happy enough to say that Fido stands for Fido the dog. That's okay. But extending that, in the case of the singular terms, it both sort of points to and stands for.
Right.
But you are only happy to see which of those in the relation of the sentence, either of them?
And the pointing I get, but I don't get why it should be the same.
It's a way of getting the same sense of standing for.
I wonder, the metaphor seems to be the interesting part here. I feel like you should intuitively get why it's the same sense of standing for in particular.
Okay, so all we know how to do, this is the conceit, is distinguish objects that can stand in identity relations, singular terms that pick out objects in the sense that the use of the singular term, the significance of its occurrence, is completely determined by identity claims, the intersubstitution licenses. And the only sentences that we really understand are these identities. Now he wants to say that the relation between the expression 2 squared and 4 is in the relevant sense the same relation as the relation between 2 squared equals 4, that expression, and what we'll call the true, which we got by abstraction and substitution from assimilating sentences that are true to each other and those that are false to each other. And the question is, can we cash out that claim that it's the same sense that applies here? And here, I think, I'm hesitating because I don't know how to characterize the relationship of what I'm about to say to the question. It's an argument, a data point. Some people have thought it solved and was an adequate answer to the question you asked, but it at least sharpens it. And this is an argument Donald Davidson made in Truth and Meaning originally, and then again in another essay called The Slingshot Argument. And he pitches it in a somewhat different way than the way I'm going to. But one way we can say, can say that the oldest Scandinavian nation is of identity, Sweden. The test of that is if we apply a function to that, say the capital of function, do we get the same value? And at least for the capital of function, we do. The capital of the oldest Scandinavian nation is Stockholm. The capital of Sweden is Stockholm. We have an expression that designates an object as a value, one that we recognize, not one of the funny truth values, but just an ordinary object like Stockholm. There's the capital of, and it's applying to Sweden. And the test is whether substituting one singular term for another changes the value of the singular term that's the result of applying a function to it. Now, consider a definite description. The X such that DX, the man who shot Liberty Valance. Now, he's already given us an analysis of this. You got to prove that there is something that is D, and you got to prove that anything else that's D is identical to it. But a good way of telling whether two things are identical is seeing whether you would change the object that's picked out by this, the man who killed Liberty Valance, if you substituted some expression, say, that occurred in D, some term that was in it. So, for instance, if we had man who killed Liberty Valance and wasn't suspected of it, in the movie, they all thought somebody else shot him than the guy who really did. I don't want we're adding to the description here and saying, well, there's another condition on this that needs to be met. Well, suppose this other condition was that Shinbone, the town in which this killing took place, is in Wyoming. We're never told, but it probably was. That's just a sentence. Shinbone is in Wyoming. Now we've got the definite description, the X, such that DX, that is, the man, implicit sortal, so we can count them, do identities with them, the man who shot Liberty Valance, and Shinbone is in Wyoming. Now, if Shinbone is in Wyoming, then the man who shot Liberty Valance and Shinbone is in Wyoming. He's just the man who shot Liberty Valance, namely Tom Donafone, I think. But if Shinbone is not in Wyoming, then it doesn't refer to anybody. There is no one who shot Liberty Valance and Shinbone is in Wyoming, if Shinbone is in Idaho. Okay, so for some values of P here, this whole expression refers to TD, Tom Donovan. What substitutions can we make here? Salva veritate, saving, in this case, the referent of the expression. Well, any true claim can be substituted in here without changing the referent. But if you put a false one in, then there is no referent. You've changed it. So, just as substituting any other singular term here, if and only if it's co-referential, is the result of applying a function to it, the function that's a definite description here, which we learned in the Grundlagen how to interpret. If we just look at the substitutional behavior of expressions in here, there's no difference between the sentential expressions and the sort of orthodox singular terms, so long as you take the sentences to refer to truth values. That is, so long as you group them, assimilate them, so that all the sentences that have the same truth value are intersubstitutable, saving the truth of this identity, that is the referent of the singular term. You see why this is sort of called the slingshot argument. You're doing something here and something quite specific happens way over there. We're going from now a singular term that can stand in identities, so we know how to understand those as intersubstitution licenses, and now we're just noticing the behavior of intersubstituting sentences in those contexts and assimilating them insofar as intersubstitution saves the referent of the expression, the object that's picked out by it, and so the truth of identities, which is what determines the inferential roles. So, this is an argument for treating singular terms as treating sentences as a kind of singular term, but a kind of singular term such that what determines its behavior in the crucial case of identities But what completely determines it is if you treat them as equivalent, just in case they're either both true or both false. That's the substitutional equivalence relation that we use to abstract the notion of truth value. Yes, Anne?
I think I share kind of puzzlement with Nikki, and this is helpful, but I think I can put my question in a different way. It's unclear to me when we call something an object, what kind of ontological commitment this claim brings? Because this is by talking about truth value as an object by this Frege argument. Actually, we only talks about how we use the language, and in this paper, in this essay, Frege only gives a very negative claim about the ontology of object, which is it's not a function. And I think in Grunbergen, he gives kind of a vibe. Objects are something countable, and that's why he's so interested in natural numbers. But now calling the truth as object, it becomes again puzzling. What does it mean we can count the true or the false? So
Well,
I think the puzzlement lies in the question, what kind of the ontological comment Frege is making by calling them object?
well, indeed, but I mean, he can tell you that. He's saying they can flank identity signs, the expressions for them can flank identity signs without needing to be supplemented by something else, by being given an argument. That's all he means by that. Can you count truth values? Yeah, there's two of them. Done his way. We have ways of counting more of them than that, but we can count them on the same principle that we can count directions of a line. The directions of the line inherit their criteria of identity and individuation, and so the way we count them, from the criteria of identity and individuation of lines together with the equivalence relation of being parallel to. But given that, we can say the direction of this line is different from the direction of this line, but it's the same as the direction of this line. Give me a bunch of lines, I can tell you how many different directions there are, which will not be the same as the number, might not be the same as the number of lines that there are. And the same way, we form the truth values from the sentences, or what the sentences, by appealing to substitution to get an equivalence relation, and then abstracting a sortal from it. Part of what I was hearing in your question, though, was saying, well, but if we take objects to be whatever is countable, whatever can be on expressions for which can be on both sides of the identity sign, can't we count functions too? Well, no, actually, you can't, because the function squared is not a function. The function's square of that expression, the function square of, is a definite description and picks out an object, or it doesn't. But then how's that related to function expressions? Well, this is a problem for him. The short answer is we're going to introduce more objects. Courses of values sort of correspond to the graphs of functions, but courses of values are objects. Why don't I do that after the break now? But sort of everything that's fishy about the truth values as objects is going to be fishy about the courses of values of functions, because, well, those are the objects that correspond to functions in the way that truth values correspond to sentences, modulo that the difference between function expressions and singular terms, but the courses of values are the objects that are associated with functions in an intimate way. And for many purposes, we can just do with the courses of values. Not if we're thinking about what kind of thing they are, but for instance, to do mathematics, in the Grundgesetze, the only objects are courses of values and truth values. There aren't any other objects. They're numbers, but that's a kind of course of values. Okay, why don't we take 15 minutes? It's 2:25, so let's come back at 2:40. Well, good. Still talking about the slingshot argument. One of the troubles with it is that the definite descriptions it depends on seem strange. Who talks about the x, dx, and just some sentence that isn't even about the x? It looks like, those are very peculiar. Why would we use those if the second conjunct in there isn't about the object that we're picking out? Isn't that a weird artificial sort of definite description? And so one worries that the result of the slingshot argument, looking at substitution in there, is an artifact of the way our first order quantificational language with identity works, and it is at least that. But I just wanted to mention that I don't think anybody boggled, at least not for this reason, when I defined phrygions last time, following Fodor. Remember, what is it for something to be a phrygion? It's for it to be a photon and for Jerry Fodor's fridge to be on. Now, Jerry Fodor's fridge to be on is not, we wanted to say anything about the photon, but it is about the phrygion, right? It's made to be something about the phrygion that falls under the kind that we defined there. If we think of the phrygions as inheriting their criteria of identity and individuation from the photons, so that as the fridge goes on and off, if we track the same photon, it's the same phrygion later on that it is now, even though it was just a photon in between. Well, that's a little bit peculiar, but take a time slice of that, so we have a property that doesn't vary over time, and substituting any sentence that has the same truth value as Fodor's fridge is on now, let's say, you'll get the same result. So, arguing, and that's a perfectly natural concept. The concept of a phrygion may seem like a weak response, but I do think it sort of softens us up for the kind of definite descriptions formed from sortals, right? I was talking about forming a sortal from a sortal with the phrygions, but we can also form definite descriptions from those sortals, but the sortal to sortal intersubstitutions also go with the truth value of the embedded sentence. So I think that speaks against the artificiality complaint. Yeah.
This is probably a really dumb question, but what speaks against us constructing examples of this sort with an existential quantifier? There is someone sort of such that they bird a person of your choice and any true proposition, because that would be grammatically suddenly perfectly fine, right? It wouldn't be as artificial. You would still say, why are you adding this proposition that is not about the guy you started talking about?
I think in effect the definite descriptions are doing that, right?
Yeah,
The Russellian,
Russell, Hilbert, and Russell.
Yeah. So no, I think that's right. I only am not sure that that's easier to swallow than the other things we're taking.
If you weren't
So-
swallowing this, you're probably not swallowing the other one.
So, look, what is true is that it's a perfectly straightforward application of the method of observing invariances under substitution, which gives you an equivalence relation, and then abstracting a new sortal concept from that, getting that by abstraction. That's the method, and this is a routine application of that method. That's what the slingshot argument is showing. So if one has a problem with this application of that methodology, you've got to find something else that's fishy about it, fishier than all the other applications of this. Okay, all of that's how he gets to the notion of truth value. And though people had used probably the words truth value before, I don't know of any, but they could have used the words, but they didn't have the concept. The concept is gotten by abstraction and looking at substitution in identities. But once Frege has that concept, so he's found that he can elaborate that sortal concept and definite descriptions that fall under it. The sortal concept is truth value, and we can say the truth value, we can label true as the singular term referring to that one, the way we could name a direction by a line that has that direction, the direction of the Earth's axis, the truth value of the claim that A equals A, that's a name for the true. Indeed, he's going to use essentially that name for it in the Grundgesetze. So we can do that by the substitutional methodology, abstract, get the sortal truth value and the two singular terms, the true and the false from it. And once he's gotten those objects, because he's made the move, the generalization of the notion of function from arguments and values having to be numbers of some kind to objects in general, we can say, well, now we can think about functions that have truth values as arguments and as values. That is, he introduces truth functions, paradigmatically negation, as something that takes any sentence that has the truth value true and turns it into a sentence that has the truth value false, and vice versa. He doesn't introduce truth tables for the truth functions here, but he characterizes them and has given us the rules for the truth functions for negation and his conditional, which he introduced in terms of affirmation and denial rather than the true and the false, but that's, henceforth it's going to be in terms of the true and the false, but it was as a truth function that he introduced the vertical stroke that is the conditional stroke there. So the combination of his generalization of the notion of functions to take arbitrary objects and then introducing these new objects suddenly gives him a new kind of function that nobody had ever thought about before, not in the general case. But even more, he says, let's just think about the truth functions as values of functions that have other objects as their arguments. And here, middle of page 2 on the handout, we saw that the value of our function x squared equals 1 is always one of the two truth values. It's not true if for the argument 0, it is true for the argument -1, and so on. Now, if for a definite argument, e.g. -1, the value of the function is the true, we can express this as follows. The number minus 1 has the property that its square is 1. Or more briefly, negative 1 is a square root of 1, or negative 1 falls under the concept square root of 1. If the value of the function x squared equals 1 for an argument, e.g. for 2 is the false, we can express this as follows. 2 is not a square root of 1, or 2 does not fall under the concept square root of 1. We thus see how closely that which is called a concept in logic is connected with what we call a function. Indeed, we may say at once, a concept is a function whose value is always a truth value. So he gets a definition of concepts out of this incredibly spare armamentarium of raw materials. Just the notion of singular term, identity, intersubstitution, and abstraction that got him to truth values, and now he has the notion of a concept. The concept, non-numerical concept, say the concept red is red, we can understand as a function that takes a visible object as argument and returns a truth value as its value. This is what a mathematician would call now, having learned this from Frege, a characteristic function. Right? In mathematics, we have a function that takes some objects and assigns them to 1, and other objects and assigns them to 0, and then we can collect all the things that are assigned 1 by that characteristic function into a set whose characteristic function it is. And he says, concepts just are characteristic functions that map objects into the two truth values. And next page, here we can designate, well, all right, sorry, that's getting ahead of myself. This is the reason the essay is called Function and Concept. Concepts are a kind of function. Again, say that to one of his mathematical colleagues, and they would say, well, what do you mean? How could red be a function? You have to do all this work, starting with the generalization to arbitrary objects, which nobody had ever thought of before, introducing truth values as a kind of object, and then thinking about functions to truth values as concepts. Metaphysically, he's going to say, and concepts, they're functions, and so they're things there, they're part of what there is, they're in the world. We get access to concepts the same way we get semantic access, the capacity to think and make claims about something, by deploying expressions, linguistic expressions for them, function expressions, but expressions for a particular class of functions, the ones that map any objects onto truth values. If we're talking about single argument functions, we're talking about properties of the objects, and these can be properties of any objects whatsoever, not just properties of numbers or what have you. And this underwrites a strong conceptual realism that says the concepts are out there, it's our job to think about them and see what really falls under them, and which concepts really imply which other concepts. Not up to us, it's a matter of what the concepts are. Is it the case that everything that's read is colored? Well, we look at the functions and see what we have there. Not up to us, even though we're, getting to ask that question and give that answer by manipulating expressions. So this is an incredibly powerful conceptual scheme that he's got, even though there are not very many parts that he's deploying in this. The meta concepts that he's using, object, function, identity, and these methods of introducing new sortals from old by abstraction, which we get the equivalence relations from noting invariance under substitution and assimilating the things that are intersubstitutable, salva consequentiae if we're in the original order of explanation, salva veritate. Now that's what we're looking at, saving the truth value of functions, well, that have truth values as values, that is, of concepts. That's how we assimilate things. So he's got this rich and powerful metaphysical conceptual scheme, meta-vocabulary for talking about what there is, dividing it into things of these two flavors, objects and functions. Can't understand one without understanding the other, but we understand the connection between them in terms of identities. His maiden effort at this was defining numbers in the Grundlagen, where the equivalence relation was being put in a one-to-one correspondence. The things that fall under the concept can go into one-to-one correspondence with one another. But now he's using this method quite apart from numbers to get us a way of thinking about sort of what's thinkable and the structure of it. As I say, I think this is not less powerful than the Tractarian metaphysics is, though I think people have explored it less. Well, I said he also introduces courses of values. Geach and Black say ranges of values. Wertverlauf is the word. In the Grundgesetz, he uses courses of values. I think that's a better translation. I'm just going to use that term. I said Frege's master principle, the principle that ties together the meta-conceptual raw materials that he's using, what I called his master formula, is A equals B, plays the same inferential role as, now he's going to be able to say always has the same truth value as f of A equals f of B. The value of applying any function to A is the same as the value of applying that function to B. Well, the schematic function f is the same on both sides of the right side of that biconditional, right? It's fa if it is identical to f of b. The value of applying function f to a is the same as the value of applying function f to b. So these are the same, these are not the same. If now suppose it's the case for some specific function that we can introduce an equivalence relation between function expressions. This is okay, I didn't use an identity here. I just said there's an equivalence relation. So it's got to be reflexive, symmetric, and transitive. But it is if, we would put this for arbitrary x, if the value of the one function for any argument is the same object as the value of the other function applied to that same argument, then we've got an equivalence relation, which is we're getting it broadly from substitution. We're noting invariance under substitution. We substitute things for A, and the truth value of this identity is the same. Well, then we can introduce, uses think it's a smooth breathing, and Greek letters. Then we can introduce this as the name of an object, a course of values. The course of values of the function f is identical to the course of values of the function g, just in case they stand in this equivalence relation, which we can understand substitutionally over here. So, what's his example? I don't know, but a function some polynomial, but those are going to stand in this equivalence relation, and so we get identities of courses of values. These days, a mathematician would call what, for the special case that they care about, would call this the graph of a function. That is, they determine the same pairs of argument and value. Different functions can have the same course of values. And now taking this, so that's a perfectly straightforward example of introducing a sortal course of values by abstraction. So we know the criteria of identity and individuation for courses of values. Just see whether for every argument value pair that satisfies the one function, it satisfies the other. So that's perfectly well defined. It's just turning the crank on his abstractive apparatus one more time to get courses of values. And then he says, remember that, I mean, he doesn't say this, but this is the move. Remember I complained about the jaw-dropping footnote very late in Grundlagen, where we've defined numbers in terms of the one-to-one correspondence between the extensions of the concepts whose numbers they are. Right? He started off arguing you have to have a concept, a sortal, in order to individuate so you can count them. But now we can talk about the number of Jupiter's moons. Being a moon of Jupiter, that's a property. That's moon is the relevant sortal, and we can put them in one-to-one correspondence and assimilate all the all the concepts that have four members in their extensions. And then we get a footnote. I take it to be understood what an extension is. And I said, gee, you were complaining about the other people saying things like, I take it to be understood what a unit is, and you were pointing out that, if we press hard on that, it doesn't make any sense. You're saying incompatible things about it, the units are the same, but they've got to be different, and so on. How do we know about extensions? He redeems that implicit promissory note here. An extension is a kind of course of values. It's the course of values of a function that's a concept. That is, it's the course of values of a function whose values are always truth values. That's what I mean by extension, he says. So he's given us a clear, perspicuous, and rigorous definition of the extension of a concept in terms of the notion of a course of values and his definition of concepts as a special kind of function. They're just functions that have truth values as their values. So think about how long this chain of reasoning and construction is that he's done, starting with the raw materials he brought out of Grundlagen, the notion of object, function, and identity understood in terms of intersubstitution, the notion of forming new sortals by abstraction, putting the substitutional notion of a function expression together with the notion of abstraction, the way he did to get numbers there, but now we're getting concepts and we're getting extensions of concepts rigorously defined in terms of those spare metaconceptual raw materials. I mean, this is just an astonishing achievement that he has. I mean, the fact that there's problems around the edges of it should not in any way diminish our admiration for this construction. This is doing philosophy. If you could do something like this, I wouldn't care how cockamamie the result was. Just have something that the parts of which interact in this way, that you can elaborate in this way. But stop, there's more. He says, yes, second passage on page 2. Incipient use of sense and reference. Now, I should say he footnotes sense and reference, which was actually published. By contrast to this, he got this published because he was invited to give this lecture, and they published that. And he wanted to advertise his on sense and reference paper, which was coming out in an actual journal as opposed to the proceedings of the society that he did this for. It's an interesting fact about him that essentially these essays that got published in 1892, and then he went back to the same well for some of the later essays, are published in a journal of Hegelian idealism that was published because it was published in Jena. That's where Hegel was. He was the great philosopher that they looked back to there. And there was a journal that studied absolute idealism and published things about it. And On Sense and Reference was published in that journal of Hegelian idealism because they would do it. Oh, yes, honorary professor Frege. Well, he wasn't even the honorary professor yet. He was just the extraordinary one. But he had the connections, he could get it out there, even though the audience that read that couldn't make anything. What is he talking about? This makes no contact with absolute idealism in any way whatsoever, but it did get published. And he footnoted sort of forward to this. But that is not to say that the view of sense and reference that's there is just the one he's giving us here. This one is simpler than what's there. This is the key to the one that's there, and I want to talk about the similarities and differences sort of next time. But we see from this that from identity of reference, there does not follow the identity of the thought expressed. Yeah, if we say an identity like that, f of a, the value of applying function f to a is the same as the value of applying g to b, the object's the same of these expressions. The referent, the object that is the value is the same, but he wants to say the thought that f of a is not the same as the thought of g of b. And that's why you can learn something from knowing that, though none of the spare metaconceptual apparatus that I've put on the table so far has anything to do with what anybody knows or believes or whatever. If we say the evening star is a planet with a shorter period of revolution than the Earth, the thought we express is other than the sentence, the morning star is a planet with a shorter period of revolution than the Earth. For someone who does not know the morning star is the evening star, might regard the one as true and the other as false. Now this is completely out of place, really, this talk about what anybody might know or think here, but he's happy to apply the general apparatus that he's got to arbitrary concepts applied to arbitrary objects. So the concept morning star and so on, those are all, we know what those are, functions to truth values and so on. And yet both sentences must have the same reference, for it's just a matter of interchanging the words evening star and morning star, which have the same reference, i.e. are proper names of the same heavenly body. So we must distinguish between sense and reference. 2 to the fourth and 4 to the second certainly have the same reference. That is, they're proper names of the same number. But they have not the same sense. Consequently, 2 to the fourth equals 4 to the second, and 4 times 4 equals 4 squared have the same reference but not the same sense, which means in this case they don't contain the same thought. Well, here he's identifying reference with the value of applying a function to a singular, to an object, a function expression to applying a function expression to a singular term gives you a complex singular term referring to the value of that expression, and that value, he's saying, is the reference of the complex expression. But the sense is a matter of what the argument was and what the function was. That's the sense. The way he's using it here to give a sense of a complex singular term is to say what function was applied to what argument in order to yield a designation of that value. And if the function was different or the argument was different, then the thought, the sense of that expression is different. And identities, sentences now, the only kind of sentence we really have to worry about in order to understand other kinds of sentences that involve applications of concepts, that is, functions that have truth values as their values to something. We understand the other sentences in terms of what we learned about identities. But the reference are just the values that you get, and the sense is just the function that you applied and the argument that you applied it to. I see. I think the concept of sense on sense and reference is actually richer than this. But there's a story that goes with that. But the thought he's starting with is elaborating a notion of sense just from these same spare raw materials that he used to get the notion of truth functions, truth values, concepts, extensions of concepts, courses of values, and so on. Again, nothing epistemic about it, but he's saying there's a different thought if you specify that value, what I'm now calling a referent, by applying a different function to a different object, and we know how to individuate all those things. well, maybe we don't know how to individuate functions, but we can individuate their courses of values. And the functions 4 squared and 2 to the 4th, those have different courses of values already. So we can use the objects as proxies for the functions. That's going to be his strategy. But we don't have to talk about people entertaining these or what they know or anything like that. Everything we need to know to understand this use of sense by contrast to reference, which he's happy to say is the sense that's involved in the morning star, evening star example that he uses as the beginning of his exposition in the other essay. This model won't make true everything he says about senses on sense and reference, but we can build something out of this that will, I claim. And I want to talk about that next time. But let me explore a little bit this conception. I mean, I, like everybody else, was taught on sense and reference early on, and had that. When I read this, I said, oh, is this the idea behind senses? It's just which function applied to which argument determines this value. If we understand those, then you understand the Bedeutung of the whole expression as the value that's computed by applying this function to this argument, and the sense is which function and which argument did you apply to get it. That's like crystal clear compared to the notion of sense as it emerges if all you've got is on sense and reference. So let's think about this notion. I won't call them senses much. Let's just think about the functions applied to arguments as opposed to the values. Right? That's what he's thinking hard about here. So the sense is a means of determining the referent in the sense in which a function has a value for an argument. When in on sense and reference he says sense determines referent, that's just it. The referent is the value of applying the function to the argument. That is, the sense is a way of computing that value. We're distinguishing the output of a computation, the value that you get, from the computations you go through to get it. Not now with the notion of computation being restricted to numbers or objects in general, but still senses are computations of values, and the referents are the values. Now, that relation between a computation, a sequence of applications of functions to arguments, and the output of that computation, the result of the computation, this is the most fundamental relationship in computer science. It's the basis of computational Trinitarianism, which somewhat confusedly has two meanings. Original computational Trinitarianism shows an isomorphism between functions, which compute a value when applied to an argument, programs, which operate on data and produce a result, and proofs. To get an actual isomorphism, they need to be intuitionist proofs, because it's constructive, computational, and so on. Don't worry about the details. This is the Curry-Howard correspondence that says you can go back and forth up to isomorphism, functions, programs, and proofs are all interchangeable. We can go back and forth between them. That's the original computational trinity based on the Curry-Howard isomorphism. Since then, it was expanded to the Curry-Howard-Lambeck correspondence that throws in category theory. It's finite closed categories, you don't care. But there's a class of mathematical categories that are isomorphic to functions, recursive functions, programs, and intuitionistic proofs. All of that comes from distinguishing the value, the result of applying the function, running the program, or proving a result that's a sentence that comes out at the end of the proof, but they're just more objects that you can compute because we all live in a Fregean world in this sense. At least all computer scientists do. So I'm saying this passage, this remark about senses and reference is opening up this vast, deep conceptual area that's thinking about the relations between functions, the functions you apply to arguments to get values, programs operating on data to get a result, and proofs that take some sentences as arguments, the premises, and produce another sentence as the conclusion. We can see all those as objects, so we can see functions as in play. And Frege is making all of that possible and intelligible in this metaconceptual framework that we're that he took over from the Grundlagen and elaborates here. Wow. That's what he was doing during these 7 years from the Grundlagen. He didn't know this, didn't have this in view in 1884, and he did in 1891. And they wouldn't give him a professorship 5 years later because nobody cared. And so, well, you should be more worried about that than I am. You're going into the profession. Okay, well, so just as my summary of what I hoped you took away from last time was a raised sortal consciousness. I hope to have given you a glimpse of this world that you can describe in the language of objects, functions, the arguments and values of functions, identities, using substitution to form equivalence relations and abstracting new objects and sortals from that. Okay, it's a rich world. In this one essay, it's all curled up in it. Okay, I promised one further turn of the crank. You might wonder why he didn't start by defining, in this essay, in his narrative strategy, didn't start with objects rather than functions. After all, he told us about sortal kind concepts that are concepts that isolate what falls under them in a definite manner, that is, have criteria of identity and individuation so we can count them, so we can settle the truth of identity claims, which are recognition judgments, judgments expressing the recognition of an object as the same again. Well, an object is what you can recognize as the same again. A singular term is what can flank an identity sign. Why didn't he start with that and then tell us about functions? I mean, we need to mention the functions because they play an essential role in the master formula there. But why not start with the objects? It's because he needs to be able to apply functions to functions as well as applying functions to objects. He needs the higher order stuff. For instance, his concavity, our quantifier, here Danielle Macbeth saying, don't call it a quantifier. It isn't. The quantifier only deals with courses of values, and the concavity applies to functions. They're not the same thing as we'll see, but that concavity applies to one function and gives you another function. Right? It applies to really any function. You can say for all x, f of x, but the function that results, that quantificational function, takes a function, f, and gives you a concept that's true in case everything in the extension is f, gives you the value true when you apply that to it. It turns one function into another function. It's a higher order function. And he needs further heights of further higher order, even higher order functions, because he needs to talk about properties that are hereditary in a sequence, for instance. And that's going to be at least one level higher than that. Now, he can do that using courses of values to stand in for the functions so that he doesn't need to ever put function symbols flanking an identity with no arguments for them. You have to do it all with courses of values. The trouble is if you don't put restrictions on the functions you can form courses of values from, you get the Russell paradox. You can construct the set of all sets that are not members of themselves, and you get inconsistency. So the fatal axiom 5 is the axiom that lets you form courses of values unrestrictedly. So there's a problem about that, but there's a conceptual issue before that he solves, but that can be hard to see. And this is what leads Dummett to distinguish simple predicates, which are the ones you use to build sentences out of. So for instance, I can build the sentence Kant admires Rousseau out of the simple two-place predicate admires and the two arguments Kant and Rousseau, think of the singular terms and the expressions. I'll go back and forth the way Frege does. That simple predicate is what I use to build up sentences like that. And then I can use a sentence like never heard of, a two-place predicate like that, and build up from Kant admired Rousseau, and Rousseau had never heard of Kant, to the conjunction of those, so on. Those are simple predicates. Those are parts of sentences. And we could substitute for admires never heard of. In this case, we get a switch of truth values in those cases, but the notion of replacing a simple predicate with a simple predicate makes perfect sense. But now I can say Rousseau admired himself. Rousseau admired Rousseau. He thought he was a hell of a guy. Kant did not in that sense admire Kant. he thought, from the crooked timber of humanity, nothing straight can be made, and that absolutely applied to him. Admiration would not be something that he said. Well, now, if I want to understand why the inference from Rousseau admired Rousseau to Rousseau admired someone is a good one, but the inference from Rousseau admired someone to Rousseau admired Rousseau is not a good one. If I want to understand that difference, I have to not just be looking at the predicate X admires Y. I've got to look at the predicate of being a self-admirer, of X admiring X. That is not a part of the sentence, Rousseau admired Rousseau, in the sense in which the simple predicate admired is. Because there's no part of the sentence, Rousseau admired Rousseau, that it shares with Kant admired Kant, that it doesn't also share with Kant admired Rousseau, which is, for inferential purposes, a different predicate. Different things follow from being a self-admirer, from just being an admirer of someone. In order to get the inferences right, which is what Begriffsschrift is all about, and Frege solved this technical problem already in the Begriffsschrift, even though in his conceptual apparatus he didn't make this distinction between the simple predicate that's a part of the sentence and what Dummett usefully calls the complex predicate, which is a pattern involving the identity and non-identity of the arguments. It's a pattern that's shared by Rousseau admired Rousseau and Kant admired Rousseau, but not shared by Kant admired Rousseau. And that pattern is a substitutional pattern. You can change Kant admired Kant into Rousseau admired Rousseau by uniformly substituting Rousseau for Kant. That's the sense in which you can assimilate those sentences as having the same predicate in them. But in that way, you can't get to Kant admired Rousseau. You can get from Kant admired Rousseau to Rousseau admired Rousseau by uniformly replacing Kant with Rousseau. Now, I'll talk about this more going forward, but Dummett's point is that simple predicates are parts physically of our expressions. In our unilateral notation, they're expressions we concatenate with other expressions to make sentential expressions. But the complex predicates, the ones you need to distinguish, the concepts that you need to distinguish in order to get the inferences right, can depend on the identity and non-identity of the different arguments that they're applied to. Is this argument the same as this argument? And that's not a part of the sentence in the same sense. Replacing the predicate of being a self-admirer in Rousseau admired Rousseau to get Kant admired Kant is doing something different. There's an intimate relation between the X admires Y, where they're different, and the X admires X, where they have to be the same. For instance, every case of self-admiration is a case of admiration, and not vice versa. So we're going to need to keep track of the relation between those predicates, but they play different inferential roles. And so our codification of the rules determining which are good, logically good inferences have got to distinguish them. But you can't substitute for complex predicates just by cutting and pasting some expression that's in there. You have to have some way of thinking about those patterns in the functions, in the expression that is the application of the function to the arguments. And so, if you're going to look at higher order functions, functions that apply to functions, what they apply to has to be complex predicates, not just simple ones. I mean, I'm talking about the predicates which are functions of the particular species that are concepts. Their predicates are functions that have truth values as their values. But this is a general point about functions. It's just the case we most care about is for the functions that we have learned are concepts. But what the function that applies to them has to distinguish between cases where we've got the same simple predicate but different complex predicates. You can do different things with self-admirers than you can do just with admirers. For instance, one of those functions is extracting what follows from, and different things follow from them. What Frege is bothered about in the concept and object essay is what peculiar kind of thing are these functions that don't just, that if we think about how we get semantically in contact with them, we have to look not just at the function expression, but at the complex predicate that it's expressing. The function expression plus these facts about the cross-reference of the variables. And how do you do that? How do you define a function that applies not just to a function expression and the singular terms that are its argument expressions, but also acts differently depending on which of the argument expressions are identical to each other and must be filled in by arguments that are the same, even though there's another complex predicate in which that's not true. You can put different things in there. I mean, two responses you should have from this are, one, gee, now I realize I don't actually understand quantificational logic. Because if you don't understand how Frege solved this problem for quantifiers, for the functions that form functions from functions that are quantifiers, so that he can get the inferences right and say why it follows from Rousseau being a self-admirer that he's an admirer, but it doesn't follow from him being an admirer that he's a self-admirer. He gets all that right. He tells us how to associate inferential roles with these different complex predicates. So sort of the first response you should have is humility. Next time you have to teach baby logic, remember you in some sense understood it and in another sense really didn't. And the second thing you should have is just being in awe of Frege having figured all this out. They still wouldn't give him a job, but he figured all this stuff out in the Begriffsschrift and spent the rest of his life trying to get clear about what he had done there. Get a set of meta-concepts that could make him understand that achievement. Okay, well, as I say, this is just the transition to what we'll talk about in discussing the concept and object essay. Maybe you can see why, when I sat down to do this, I realized, no, I can't do both of those in one class, but we'll see. I have to give, next week, I have to give a lecture in Paris, so we're not meeting next week. This has been on the syllabus, so it's 2 weeks. So I put some more stuff on the reading list to read this one essay by Danielle Macbeth that is analyzing the proof structure of the third part of the Begriffsschrift in a way that's really important for thinking about conceptual novelty, how we can get genuinely new concepts out of old ones by logic alone. And I'll specify the relatively few. I think it's 8.2 to 8.4. Anyway, the last part of chapter 8 of her book that I linked to. And on the syllabus, I haven't specified, I just say selections. I don't say which ones, but I'll add that to it for you. But I'd say reread this essay, read the concept and object essay, and reread On Sense and Reference with this background, with the background of this incredible conceptual scheme that he has put in place, which, whatever problems it has, it's a thing of beauty and a joy forever. So I'll see you in 2 weeks, and we'll talk about all that stuff.